This is a session on what you can do to help Inspiration Mars. And of course, the Inspiration Mars people are here to answer all your questions as well, broader than that. But to begin, I'd like to make an announcement of what the Mars Society is going to do to help Inspiration Mars. That is, discussed this with Dennis earlier this year, and we decided this would be a really good idea of something to do. Is the Mars Society is hereby opening up a international Inspiration Mars engineering design competition. Okay, this will be open to teams of engineering students from colleges anywhere in the world. It's not limited to Americans, and the charge is to design a two-person Mars flyby mission to be done in the year 2018. Okay, so you are, other than that, all variables are open. You can use the trajectory that the Inspiration Mars is currently focusing on, or you could use an alternative trajectory. You could propose launching it with any credible combination of launch vehicles that might conceivably be available in the year 2018. Okay? You can use whatever kind of life support system you think is most appropriate. Okay? But it has to support a crew of two. It has to bring them back, fly by Mars, and bring them back safely to Earth. The scoring of the designs will be as follows. Be up to 100 points are possible. 30 of them are based on cost. Okay? 30 are on the technical quality of the design itself. 20 on the credibility of schedule. That is, we want to do this mission in 2018, and so you have to propose technologies that will be available by 2018, and you have to propose a development sequence that is credible to be done over a 5-year period, and 20% on operational simplicity. Okay, so for instance, the fewer launches that you can do this with, the better, because in order to actually implement the plan, the more launches there are, the more difficult it will be to get it off within any given launch window that is appropriate for your mission. The teams do not have to be composed exclusively of students from the university, but they have to be led by students from the university, but alumni from the university can participate, research faculty, people from the community who are not part of the university, but it must be led by the students. And what is required is that, okay, the presentation be done primarily by the students. The paper reports describing the mission plan and mission design need to be delivered to the Mars Society by March 15th, 2014. Okay? And then there will be a down select of the 10 best, and those will be invited to come to NASA Ames in April of 2014 to make live verbal presentations of their designs before a panel of 6 judges, 2 of whom will be selected by the Mars Society, 2 of whom will be selected by Inspiration Mars, and 2 of whom will be selected by NASA. Okay? And then they will be scored, and the winners, the top design will get a $10,000 prize and an all-expensive paid trip to next year's International Mars Society Convention, where they will get the award from Dennis Tito, and there will also be lesser prizes for 2nd through 5th place. But that's the basic outline of it. The key thing here is as follows. This is a chance for people with technical skills all over the world to lend their talent, to lend their innovations, to lend their ideas in support of this mission. This is a really tough mission. Inspiration Mars has got a good team, and they're working on it. But they're open to other ideas that might be better, and they want to hear from you. And this is your chance to participate in this. And we hope that we have teams competing in this from all around the world. So, thanks. Do you have comments on it, Dennis?
Yeah, I'd like to emphasize that in any project, the saying goes, the devil is in the details. And there are a lot of details that we don't even have time to think about and work out. And they could be very subtle details as far as how the crew is going to cope with being so far away from Earth, and will they be able to deal with the isolation, or be frightened to death? And we want to get a lot of ideas as to how we can make this mission a success, because this is dealing in a realm that humans have never dealt with, and that's why we feel the flyby mission just by itself is an important stepping stone to eventually boots on Mars. But we have so much to learn, and if we can avoid some mistakes, this is one good way of getting a lot of input. And again, one of the key driving factors for this mission is crew safety. This is not just some risky endeavor that, well, if it succeeds, it succeeds, and if it doesn't, it doesn't. We are working very hard to provide a high probability of safety and successful return for the crew.
Okay. Do you have any comments, Tabor?
It's been really interesting on this journey so far, how organizing and priority setting having a mission is. And we've seen lots of mission studies that we've looked at to say, is there an idea here or an idea there that's useful? And what we keep finding is that, so the mission study went to a certain level, but it was sort of generic and a conceptual design, and the authors really didn't sort of have to get faced with the next level of reality. And so it creates this amazing filter of things that actually get through that first real tranche of how would you really put it together. If you're going to assemble something on orbit, what are the orbital mechanics driving your ability to assemble something on orbit? If you're going to say you're using a fuel depot, what are the orbital mechanical issues of where that fuel depot was put? And we very rarely get into that level of detail. So I think it's a great opportunity not only for American industry and NASA to have to tackle that level of detail, but it's a fabulous opportunity for student teams to also have to tackle that level of detail. And Carol Stoker reminded me this is essentially the Apollo 8 of our Mars missions in the future, and that while in one way is very simple mission, still elucidates most of the details of a large segment of getting there and getting back that any Mars mission will have. So I think it's going to be an interesting opportunity for students to be faced with sort of that stark reality of what works and what doesn't.
Yeah, I just want to make one broader comment. Because, obviously the Inspiration Mars people think their mission is very important. I'm not part of the Inspiration Mars team as such, but so as an outsider, let me just say that I also think that this is extremely important, that this is the most promising development that has occurred towards opening the road towards humans to Mars in some time. And it is a terrific mission. It is bold yet realistic. There is enough resources behind it at now to make it a realistic prospect that this thing could really happen and really succeed. Okay, so, and if this does succeed, I mean, some people have come, well, you're just flying 2 people by Mars, where's the science? What you're doing is you're taking the dragons off the map. If this mission happens, this will completely change everyone's thinking within NASA, within Congress, within the public at large, as to what a human Mars mission is. Is it part of our world or part of the world of the future? Right now, NASA's thinking has humans to Mars being part of the future. It's not part of our reality at all. You know, they talk about humans to Mars as being something that might be done by people who are currently in the 2nd grade. What this mission will do will change their thinking to that humans to Mars is something that's going to be done by people who are in the astronaut corps today. Okay? That's what this mission means. This will completely change the entire picture. And the Gantt charts are going to become a lot shorter. And okay, so this is a chance for a breakthrough. And we really need to give it all the support we can, starting with using and mobilizing all the technical talent that we have or have access to. If you're a student, make sure that your university participates in this contest. If you're an alumni of a university, contact them and tell them about this contest and get them involved and get involved yourself. But we need to mobilize the talent of the world in support of this mission, and also that will do one more thing. Because Inspiration Mars, in part, was set up to inspire people and show how the challenge of humans to Mars could inspire a new generation to want to develop their minds, to become scientists, engineers, technological entrepreneurs, researchers. Okay, well, this contest itself will show people that Mars has that potential. Will make it clear to the political class that if we want to remobilize American education and remobilize this country, if we want to, reject this social decline that some people seem to have accepted as if we want to just wake ourselves up like we did after Sputnik, Mars is the way to do it. That this one mission can show that it has that potential, and we can start showing them that it has that potential now. And, as Dennis said in his talk, this mission is going to need the support of NASA. Okay, it will. Okay, and by showing people how this Mars can help NASA fulfill one of its key missions, which is to inspire American youth and mobilize American technology and American technological potential, okay, and create intellectual capital, okay, that will encourage collaboration from NASA, and that will encourage congressional support for collaboration from NASA, okay. So this is what is happening. This is something we need to support, and this is something we're going to support. Okay, so are there questions?
Bob, I'm going to assume that I don't have to, when I get home, run down to Syracuse or run down to Cornell to let them know what's going on. We've got a way to do that, don't we? Not just me and my notes.
Well, we are sending out a press release. It's going to be sent to all our press contacts. It's being sent to our full email list of all the people that listen to us. It's going to be posted. Inspiration Mars has a public relations firm, Griffin Communications, and they are sending out the release as well to a very large list of press contacts. So hopefully people will read about it in the press. But in addition to that, okay, so people are going to hear about the contest. But if you're an alumni of one of those colleges, for example, okay, you can help bring the message home. Say, hey, let's do this. Let's become part of this. So, yes, we're getting it out broadly, but people here who hear about it, whether you're in this room or you're listening to us on the internet, get involved, get your old college involved, do whatever it takes.
Yeah, I had 6 embargoed interviews over the last couple of days about this contest, so I think it's going to get some good press.
Sir?
Yes, Robert, the way to really get student attention, it's neat to have an intermediary of an alumnus or something. Isn't there some way the Mars Society can do what really gets in students' faces, which is to make sure that this is posted on the bulletin boards in every geology department, every geophysics department, every chemistry department, every aerospace engineering department. Get it right in front of the department chairman that it needs to be posted in front of the students.
Okay, well, we're going to do everything we can on that. I have a friend who is, has been prominently active in the University Space Research Association, and I'm sure I'm going to list his aid to make sure that the word gets out to all the university engineering departments that participate in that activity. But we'll do everything we can. We want people to know about this. We want them to participate in this.
Yes, I would like to be sure to have understood in which way we will help Denise Tito by performing such study. Is it that we give this study to you and you pick up some ideas which are emerging from these studies to solve some problems? Is that the good way?
Well, Inspiration Mars will have non-exclusive rights to use any of the ideas contained in these studies.
This is not my question. I would be sure to understand in which way these studies will help the Inspiration Mars.
I think there's a couple of ways that the studies will help. Now we're marching along in an architecture that is going to get very solid in the next few months. And so we're leading these studies a bit in terms of our architecture, but there's always new details that come out, and so I think two things are going to happen. The student studies, as they start to work and maybe have questions or put out posts, might make us realize that we had an assumption that we really need to question. So there's still, I think there's going to be some feedback in sort of the architecture closing phase. Maybe the more important part is there is a lot of subsystems and a lot of functions that we haven't really begun to dig into yet. We're as Deming said, getting the big rocks in the jar, and we're just starting to put the smaller rocks in, But the students, the reams of students are going to start pouring the sand in and really getting us informed about ideas, way to do exercise, ways to handle water, ways to determine the directionality of radiation. There are so many fabulously important aspects and creative ways to do parts of the mission that I think we'll be gathering those and putting them into the process. We actually have a formal now opportunities database that when somebody sends us an idea, we say, that looks pretty interesting, but we don't have the attention for it right now, a new pharmaceutical or something like that. It goes to the lead of that area, but it also goes into the database, so when the lead says, okay, now I need to start worrying about this thing, it gets into the database. So I'd imagine a lot of these reports are going to produce information that ends up in our opportunities and risks database.
Okay, I'm okay with that. Okay.
What about a team that is a collaboration of multiple colleges? Is that an eligible contestant?
I would say yes. If a group of colleges want to collaborate and form a single team, they could. I don't see any reason why
not. First, I wanted to say I'm just so excited about what you guys are doing. I think it is game-changing. It is the most interesting thing and the most exciting thing that's happened in many decades in terms of human exploration of Mars. I wanted to just offer a comment. Getting the crowdsourced information and getting the entire world to feel participatory in this is one of the aspects of it that I think is just unprecedented. But it's going to be very difficult because it's already a very complex undertaking, and the more people you involve, the more ideas you involve, the more complex it gets.
You're spot on.
I just wanted to offer one suggestion, and that is, I know of 3 groups that are doing Mars mission designs that are trying to do a crowdsourced Mars mission design. One of them is led by Michael Sims, who's a Ames researcher, computer scientist. And he's got a couple of other, like Stanford professor computer scientists helping him. And they're doing this as a computer science research problem of how do you synthesize, a crowdsourced kind of information. So I'm volunteering Mike Sims to help you. He's not here and he doesn't know this, but I think it's the kind of thing that could be very useful.
Crowdsourced engineering is a really interesting emerging way of doing engineering that I have not really been able to wrap my arms around how you do it, but when we made the announcement in late February, we got reams of emails, which is what made us sort of start this database. We didn't know what else to do. And so we've got this database of all these ideas of people that sent their, have you thought about this or what about that? And so I would not, we're not at all prepared or geared to do that. So this is a fabulous offer, and it'd be really interesting to find a way to do that, because they're, the social media tools that are available and the computing tools that are available now make this an opportunity to involve the world, as you said, in an unprecedented way. But I'm not sure we understand how to use those tools and how to do that. I'm sure that there's nobody actively working on the team trying to solve that problem for sure. And it's a tremendous opportunity to take, not only on the engineering side and the design side, but then during the mission and during the mission prep and during on the ground sims, and when the crew is flying by Mars. I have this very pedestrian image of an auditorium full of middle school science students that are sending messages to the crew and back, and the crew is talking about how they're recycling their urine and how everything on Earth is just this little tiny dot. And think to myself, imagine if I had been in that auditorium when that was happening, how that would have inspired me. But that's such a 1970s view of how to do this, right? I mean, it's a cool vision, but it doesn't approach the opportunity.
Okay. Next question.
Sorry, Mr. McCollum, maybe outside the scope of the contest, did I understand you correctly that we can submit individual subsystem designs as undergraduates?
We don't have a process for that yet. I guess what I meant to say is when we get an email that talks about a subsystem, so it is an idea, we route it to the right person and we log it so that we don't lose it. But we don't really have a formal process of sort of taking somebody's subsystem design and considering it. We're just not sort of also staffed to do that in many regards. So I think if there's a very specific idea that sort of raises above the level of wouldn't this be a cool technology to do, we can try to sift through and find the right connections to make. So to be brutally honest, I'm torn on the one side. I want to get all these ideas and people engaged and love it, love people. On the other side, the team's overwhelmed and dealing with really big issues that we're trying to solve on an architecture level. So, to be brutally honest, right now we're sort of just categorizing those as TBD, to be worked in the future, and that's just a fact of where we are, and not any lack of desire to engage the world in doing this.
Yeah, it's very difficult to take in a large number of scattershot ideas, but if you form a team at your university and develop a unified discipline design, well, first of all, you submit it to this contest, it will be read, okay? And furthermore, it's in the context of a broader design that you can demonstrate the superiority of the alternative that you're offering, okay? And it puts it within a context, in a discipline context, where you can really see its advantages and disadvantages. So if you want to participate, get your school involved.
Yeah, and I'll just sort of second that. The problem that we have is that these ideas come in and 90% of them don't realize the complexity that is attached to it that makes it not work. But what makes this competition work in teams is that first filter is inherent in each team, right? And so we're able to get now filtered work that's already been through that first filter. We made the mistake once of responding to somebody's email saying, this is right in the very beginning, you did your oxygen recovery calculation wrong. This is what's right. And it took maybe half an hour of somebody writing an email back, and then they write the email back. His stoichiometry was wrong, but we realized very early on that if we start responding to these things, we'll never get any work done. So that's the magic of this idea, is that it creates a self-filtering hole that we can then look at that's already been through that first gate of filtering.
And there's one other thing that is a great advantage to both Inspiration Mars and to the students who participate, which is this, you'll be able to show your talent and they'll be able to see it. And they're going to need talent to do this mission, whatever design is adopted. And so you put yourself forward on this, you're showing them what you've got under the hood, you could end up getting involved in the mission.
Yes. It appears to me that the biggest challenge of this program is the schedule. I think nobody will disagree on this. And you know, my experience from all past programs I know is you should start with the development tomorrow, more or less. Yeah, because there's a lot of development work to be done, and the assembly in space is not easy. And I would say if you do it the way that Elon Musk is doing it with the Dragon and his missiles, his rockets, it could work. But what is your planning? I mean,
So
when can we start really? Tomorrow or after tomorrow?
So we've already started. So we early on, two fundamental issues came to light that had to get addressed on a long timeline. One was TPS, or three really, TPS, radiation, and life support. So by February, we had a Space Act agreement and a team at Ames working very hard on the TPS and whole reentry issue, and they've made amazing progress. We're also working with other parts of NASA and ESC and like to do the same. Dr. Clark put together a radiation team and began to both assess the actual risk, what our countermeasures would be, what our shielding should be, how we approach that problem. And then, of course, in life support, January 1st, we began a project to get the main technologies, the main chemistries of a regenerative life support system on the bench in working hardware by the end of the year. Hardware is coming in. I was so frustrated 2 days ago when the ITAR officer said none of those pictures of the hardware that's coming in with the life support system could be shown in a public venue. I was like shaking. I was like, really? But at any rate, go talk to our State Department. So we have hardware coming in on a two-person scale for things from trace contaminant control to CO2 removal to carbon reduction to electrolysis and the like, so that we're working with the full set of chemistries, and it turns out it's a pretty unprecedented combination. There's similar work going on at Marshall, but not as integrated. Once we have benchtop checkout of this hardware, we're working towards chamber testing with people at some point next year with that hardware, so we get into the long duration testing that's needed. So the approach has been tackle the hard problems we know we have to tackle that are long leads. The next, after all that work was kicked off, the next thing was really work on the overall architecture, especially the launch architecture, which is the next thing. And all options are on the table, certainly, including SpaceX, and we're in pretty regular email with them on questions about this and questions on that. So we really are engaging the community, and it's an unprecedented time. As I think I said in February, there are more spacecraft in development now than the entirety of human spaceflight history up to this era. And each of those spacecraft has their own unique capabilities, their own unique design approach. Some lend themselves to inherited to another mission more than others, but it would not be possible to do this mission without the International Space Station having worked through 13 years of continuous semi-closed operation. The incredible flexibility that NASA management is showing in allowing a privately developed spacecraft with pretty minimal insight from NASA to actually berth with station. I mean, most of us remember 5 years ago, that was a joke that peeled you over laughing. The space station program was never going to let a private vehicle in the orbital ellipse of station. I mean, it's hard. We're sort of in the middle of the fight. If you step back just a little bit, we're seeing incredible flexibility and incredible innovation at NASA, given the constraints that NASA's in with Congress and everything else. It's an amazing time. We're seeing shifts happening in the industrial community and in NASA so fast it makes your head spin. It's a marvelous time to be involved in space.
Okay. Was there a woman over here, Miss, were you wanting to ask a question with the hand up? Yes, no? Oh, that's, whoever's got their hand up, right here. Oh, I see, it was the person behind you. Okay, go ahead, sir.
You've already answered this to an extent, but is there any even secondary interest with the contest with pure science payload, particularly if it's relevant towards later manned missions to Mars? And then some clarification on what you're looking at as realistic from a rocket standpoint. So when people are putting together things, for instance, if you're looking at like a reusable Falcon, we kind of got to the point where you have to look at what's in inventory today, not necessarily what might be certified in a few years.
Well, there are vehicles in development today, SLS, Falcon Heavy, the reusable, other vehicles that people talk about. It's up to the teams to make the argument that their choice is realistic. Okay, that's what it is. This is an open design. Okay, they're not constrained to for instance, the exact trajectory. There are other trajectories that, for instance, are lower energy but take longer. That, who knows, they might discover a trajectory that is lower energy and takes shorter. I'm not aware of one, but if you can find one, I'm sure they'd be glad to hear it. You can use whatever kind of life support system that is credible. Okay, once again, you make the argument that it's credible. It can be credible based on very extensive heritage, or it can be credible based on more limited heritage, but clear calculations. But the design does need to be comprehensive, including a method of launching it and putting it together if it does involve on-orbit assembly, a trajectory, the spacecraft designs, or choices of existing spacecraft if that's how you choose to go. Life support system, sufficient food and other consumables given whatever the life support system is, the re-entry technology. You want to cover as many of the bases as possible. Now, of course, given that this is a design contest and it's now August and it's due in March, so it's roughly 7 months to do it, there probably will be gaps in everyone's design. But people should try to be as comprehensive as they can be and as competent and creative as they can be. Inspiration Mars is not looking for people to necessarily play back to them their current preferred answers. This is not a case that, for instance, some contractors currently adopt of always telling the customer what they appear to want to hear. Okay, tell them the best thing you can tell them, because if you can supply them with ideas that are better than their current ideas, they won't be angry at you. They'll be happy with you. Barry.
I think the current height limitation for NASA astronauts is 5'4". Can we send midgets? I'm serious.
I think there's a strong argument to be made for smaller crew members. But I think you have to make reasonable allowances. And as I say, it's an open design, but you need to be as credible as you can be.
We have had people suggest paraplegics would be better because you don't really need to keep all that leg muscle alive. You can go down some pretty weird rabbit holes with these kinds of things. But we are, in terms of the mission, we're designing around the 95% male and female, just so we don't constrain the crew selection physically.
Okay, so do you want to then establish that we will establish the life support requirements based on average humans?
I think you let the team establish the requirements. They may have a great reason why going to the 95% crosses a threshold that makes their architecture not close. I mean, so I think all these derived requirements should be left to the team members.
Well, the design that we're following now has a lot of margin in it, and I think a good approach for anyone that applies this contest is that there is a fair amount of margin, and as far as the crew part of it, it should be open and focused on what are the main criteria that would go into crew selection. I don't want to over-constrain it, but there may be some insight that will come out of this contest that we never even thought about as what might be important for the crew. So I encourage.
Sir, over here. You.
Here.
Yeah, you were discussing before the way of trying to interface to the community. One of the most successful way of doing it has been the one of the open source software that has been very successful. And now we are going also through open source hardware. What is preventing your project to become an open source project and being shared with the rest of the community, and maybe without action from your side, the community can really, go through it and provide ideas, or in any way, in my opinion, providing as much as possible open would make the project being tested by the community itself, or anyhow provide that the community can give you some useful feedback.
Well, I think in essence that's what Carol's volunteering somebody to help do. It's what prevents it is you get past a certain level of complexity and detail, and you have to have your entire team on that same page. And it's even hard keeping our 30 people on that same page, right? And so a lot of it's driven by keeping us from going down too many blind alleys and working in what now a small team can do that a small team couldn't do even 20 years ago. So I love the idea of open source. The bridge to that is how do you get that to work in the time frame we have. So I see, you could have one of these teams be simply an open source team. I mean, in theory, why not? It's a university-led open source team, and that becomes the mechanism by which ideas get brought in. At the end of the day, as I sort of showed in the chart, there's only so many permutations that work on existing hardware. And so, we can sort through those and have a pretty good feeling that we're understanding the playing field. But just in the time we had, this was the approach we thought was the best way to go.
But there will be any, proprietary design that you will have to protect or something like this?
The work that's being funded by the foundation, and Dennis, you can jump in here if I get this wrong, is, to the degree it's not ITAR, in many ways open source, it's a philanthropic foundation. Certainly for NASA, I think that we're going to come back from this mission with a life support system that's tested over 500 days in a radiation environment, a great understanding of crew physiology. When people talk about research, the doctors have a list of research they want to do that's like, nonstop. There is so much interesting physiology research and psychology research of the crew that they want to do. We're going to learn more about deep space travel in the course of this 500 days than, everything to date. And so there's a lot of interesting research that's going on and will go on.
In the back, Nicole, I believe.
My question is more a little bit in the future. After Inspiration Mars successfully completes this mission, you are planning a future humans to Mars to land on Mars. Is that a settlement mission or more of a plant a flag mission?
Well, the way I look at it, there are going to be many steps involved before we actually have humans land on Mars. I know there are some people that are saying, we might land, within a decade. I think it's incredibly complex. And, just working on the 2018 opportunity, which is the simplest of all possible trajectories and mission designs, every day you learn of more issues. So I think that if we have a perfectly successful 2018 mission and with good data and no real psychological problems with the crew during the mission or health problems, the next mission to Mars would probably, in my opinion, be 2033, and that might be a orbiter mission to Mars, and possibly a rendezvous with Phobos. So it wouldn't be boots on Mars, but it might be boots on Phobos. But the landing is, I think, 2 orders of magnitude more difficult than the Inspiration Mars mission. So I don't know, it could be the end of the century before we actually land people on Mars, in my opinion.
I'm more optimistic.
Excellent.
And I'm more optimistic for the prospects of Inspiration Mars because than perhaps they are. Because I believe, okay, look, first of all, this mission is going to take the dragons off the map. Okay, the medieval cartographers put dragons on the maps of the oceans. Here be dragons, you can't go there. This is going to take the dragons off the map. Okay, while from an engineering point of view, this is a simpler mission than a human Mars mission to the surface. From a human point of view, it's actually more difficult. They're going to be spending more time in space than a crew would, for instance, on a Mars direct mission with 6 months transits each way. Okay, and the human factors, they'll be more confined. They will not get a chance to go out and explore on a surface. All these things which might relieve human factors issues. This is pushing the edge way in other words. If people can do this, people can do humans to Mars, and it's just a question of doing the engineering. Okay, but with the dragons off the map, with people just rethinking altogether what humans to Mars is, taking it out of the realm of the future, putting it in the realm of the present, NASA being remoralized to be willing to take on bold challenges, and everyone being shown what is possible that a private initiative or a public-private partnership can do. Okay, resources can be mobilized. There's 7 billion people on this planet. 1 billion of them live in the advanced sector where people have resources. They don't have to worry about whether they're going to starve to death tomorrow. Okay, and of those 1 billion people, at least 10%, probably 20%, believe that it is fundamental to a positive human future that humans expand into space. So let's take the lower number, 10%. That's 100 million people, okay, who believe this is essential. 100 million people times $100 a year would be $10 billion a year. Okay, that'd be enough to finance the exploration and settlement of Mars, no sweat. Okay, and if Inspiration Mars is successful in doing this, they will have gained the credibility to tap into those resources, to call upon people to pitch in and mobilize resources. And they'll certainly have mobilized the technical community around it with vastly greater technical resources. There'll be greater financial resources. There'll be greater political connections. There'll be everything will be better. And I believe, frankly, that if you can do this, doing humans to Mars in the 2020s is entirely in prospect. Okay, the picture will change. Looking at it right now, it seems far off. Once this is done, it will no longer seem far off, and it will no longer be far off.
I realize this is not your problem, but I'd ask you to just for a moment put yourself in the shoes of the contestants that want to enter your contest. Do you have any tips for team building?
Well,
team building is largely built around good leadership skills. And I think finding the right leadership for each team will ultimately be, you know, a large part of what makes the team come together and stay together and work hard.
Mark?
At some point, you're talking about you're going to need additional funding, and my question is, at what point would it be appropriate to speak with our representatives about supporting this mission, and is there any kind of a ballpark range of figures you have for how much the mission will cost to discuss with them?
Well, certainly, I mean, they can address it more specifically, but certainly having a positive attitude in Congress towards NASA collaborating and supporting with this mission would be a very positive development. And so if you do speak to your congressman, and everyone here should be talking to your congressman, if you're not talking to people who are in politics, you're not part of the ruling class, okay? Tell them that, first of all, we want Mars to be the goal, and we want Mars supposed to be the goal of NASA in its own efforts, and we want NASA to be supportive of private efforts that lend towards reaching Mars and public-private partnerships such as Inspiration Mars.
See, one of the we mentioned the 60-day architecture study that we're currently undertaking. This is going to be a key part of this process of taking the next step in going to Congress and asking for their support. The main objective of the 60-day study is to really certify that this mission is doable with mostly existing hardware or hardware that is in the development stage, and that it could be accomplished in time for launch in 2018. You know, once we have that certificate, mainly from NASA, that this is not science fiction, this is the real deal, it can be done by the most credible people across NASA, then I think we have a basis for going to Congress and saying we need, you know, some additional money to support this. I don't think it's going to be a lot of money. When you look at robotic missions, I think it's less than the typical robotic mission as far as the funding that would be required. Robotic mission to Mars.
It's certainly less than the cost of the asteroid retrieval mission. Okay. A question here? Kai.
Question about the mission. You'll be flying humans much closer to the sun than ever before. While you're close to Venus orbit, what special issues do you see from coronal mass ejections? I mean, they'll be reaching the spacecraft before they get to Earth. Shorter warning time, increased radiation intensity.
Yes. Yeah, so they're clearly not as dispersed. So it's been called sort of the golden BB, where you and the closer you are, the magnetic field lines are tighter. So statistics happen in a different way, but clearly one of the things that we know we have to do is carry the monitoring on board. We can't rely on Earth's helios monitoring assets to necessarily give us the warning, and the crew is going to have to be, pretty much drilled, how to get into the habitat. One of the things we're actually talking about over lunch is to the degree we can establish directionality, that the crew, puts shielding in that direction and actually lines themselves up feet first in that direction and things like that. So there's a variety of things, but the time frames and observables are such that it's really something that the spacecraft has to be set up to do and always ready to get into that mode, and that we have to have enough redundancy in the systems that, while the crew is hunkered down, the life support system can continue churning away, if they really end up having to be, put into a little tiny space with all the stuff we have in there around them.
It also turns out that during this 2018 opportunity, occurs at the solar minimum. So that offsets, some of the negatives that result from flying as low as the Venus orbit.
Okay, we're getting close to the end. Let's have 3 brief questions and relatively brief answers. In the back over there.
Never mind NASA for a moment. What has the FAA's Office of Commercial Spaceflight been telling you about licensing you?
It's actually an interesting question because the definition of deorbit is the last time you've made a definitive maneuver or burn to cause deorbiting and reentry to occur. And since what you license is the launch and the reentry, the launch we pretty much understand. The reentry process begins 501 days before you actually enter the Earth's atmosphere. And so the FAA right now is sort of thinking about what does that really mean, that there essentially isn't a phase that is not part of the reentry anymore. And so we're having lots of fun, but they're being very, very supportive, and they'll work with us. George Nield has a really great team of folks, and they work problems. We're very confident in our ability to work with the FAA, but it is a fun question. That's one of the things that's being considered, yeah.
Barry?
What prevents you from taking a retro rocket to do a retro burn before you use the shield coming into Earth? Why can't you carry either a solid booster or a liquid fuel module to slow down, since your high speed of entry into the Earth's atmosphere is a major part of it?
The question was, why not take a retro rocket and slow down right before you get to the end? It's certainly in the trade space. What it turns out is that, for the most part, the mass of fuel it takes to do the retro burn to a significantly different velocity that makes a difference to the mass of the heat shield is more than that difference in the mass of the heat shield. So it looks like you're better off just carrying the more massive heat shield than all the mass of the retro burn. Secondarily, now I have to be, if I count on that burn occurring, that burn's absolutely got to occur, and it occurs pretty late in the mission to be useful. So now I have another definitive burn that has to occur rather than just some course corrections. So it's certainly been in the trade. Aero capture's been in the trade, and we looked at it pretty hard early on, but it just, at this point, isn't trading out very well.
The free return part of this mission is one of the key aspects.
Yeah. Last question right here.
Care package. There are a couple of places that are close to me that have potential teams. Do I have a care package ready to download to faculty who might locate the right person to lead the team, etc.?
Well, there's going to be a release which presumably has been posted on the Mars Society website already, if not certainly before the end of today, that will give people the basic idea of what the contest is, and more details to the rules will be posted on the website, especially if people have questions about aspects that we haven't thought about. All right, thank you very much. On to Mars.